Hello students and welcome to today's lecture. In this session we will study the use of tools, tackles, cranes and fasteners used on board ships and in shipyards. We will look at hand tools, power tools, hazards, testing of lifting appliances, proof load requirements and different types of fasteners used in marine engineering. This topic is very important because tools and lifting devices have no redundancy. One single failure can lead to a major accident. So, understanding their correct usage and testing is essential for safety and reliability. Let's begin with hand tools. Hand tools include manually operated tools such as axes, wrench, hammers, chisels, and so on. Most hazards come from misuse and poor maintenance. For example, using a chisel as a screwdriver can cause the tip to break and injure someone. Using hammers or axes with loose or cracked handles is dangerous because the head can fly off. Worn wrenches with sprung jaws can slip and cause injuries. Another important hazard is mushroomed head on chisels, wedges, and drift pins. Pieces can break off and hit the user or a bystander. And finally, iron or steel tools create sparks which can ignite flammable or explosive materials. In those environments, we must use non-ferrous sparks resistant tools. Next, let's discuss power tools. Power tools may be driven by electricity, pneumatic, hydraulics, liquid fuel, or power actuator mechanisms. Some important precautions related to this are: never carry a tool by its cord or hose. Don't pull the cord to unplug it from the socket. Keep cords away from heat, oil, and sharp edges. Always disconnect tools before cleaning, servicing, or when changing blades, bits, or cutters. Keep bystanders away from the work area. Use a clamp or a vise so both hands stay free. Avoid accidental starting by not keeping your finger on the switch when carrying a plugged-in tool. Tools must be clean, sharp, and well maintained. Wear proper clothing, no loose garments, no ties, and no jewelry around moving parts. Damaged tool must be removed from service immediately and marked do not use. Lifting appliances are critical equipment because they have no redundancy. A single failure may cause serious or fatal accidents. Therefore, lifting appliances must be inspected and tested annually by a competent person and must comply with merchant shipping regulations. Flag state requirements: ILO Convention 152. All lifting appliances and loose gear require proof load testing before first use, every 5 years, after repairs or modifications. Items that must be tested include engine room cranes, ropes, winches, brakes, safes, bridge structures, trolleys, traversing units, and wheels. Now let's look at the proof load. For cranes and derricks, up to 20 tons, it is tested with 1.25 times the safe working load. 20 to 50 tons, it is tested with a safe working load plus 5 tons. Above 50 tons, it is tested with a 1.1 times safe working load. Hand operated pulley blocks are tested to 1.5 times the safe working load. Initial test must hoist, luff, and slew the load not simultaneously but in sequence. Sometimes water bags are used as alternative test weights. Luge gear also has a specific proof load requirement. Single C block, it is tested at 4 times the safe working load. Multi C block less than 25 tons is tested at 2 times the safe working load. 25 to 160 tons is tested at 0.933 times safe working load plus 27 tons. 160 tons is tested at 1.1 times the safe working load. Hooks, shackles, chains, rings, swivels. Less than 25 ton is tested at 2 times the safe working load. 25 tons is tested at 1.22 times safe working load plus 20 tons. Lifting beams, spreaders, and frames. Less than 10 tons is tested at 2 times the safe working load. 10 to 160 tons is tested at 1.04 times the safe working load plus 9.6 tons. 160 ton is tested at 1.1 times the safe working load. Now let's move to fasteners. A fastener is a mechanical device used to hold two or more components together. Fasteners are used where joints must be non-permanent and removable without damaging the parts. Example of permanent joints are welding and riveting, while non-permanent joints are nuts, bolts, and screws. Fasteners consist of a male part and a female part. A male part are those like bolts or screw with a external thread, and the female part is nut or threaded hole. Now let's move to the fastener terminology. Important terms include Major diameter, the largest diameter, also the nominal size. Minor diameter, the smallest diameter, or you can say the root diameter. Pitch, it is the distance between the adjacent thread. Lead, it is the distance a screw advances during one full rotation. Materials and coatings. Uh, Fasteners are made from carbon steel, alloy steel, stainless steel, Inconel stainless steel. To improve corrosion resistance, fastener may have zinc plating, phosphate plating, chromium plating, silver plating, black oxidizing, nickel plating. Now let's move to the classification of fastener. It can be removable like nuts and bolts, screws. It can be semi-permanent like cotter pin. It can be permanent rivet, welding. Fastener selection depends on various criteria like the primary function, appearance, number of fasteners needed, operation condition, frequency of disassembly, adjustability, material, consequence of failure. There are three main tightening methods: torque wrench with a specified torque, turning a specified angle after full engagement, hydraulic tensioning where a bolt is stretched hydraulically before tightening. This method ensures correct clamping force and prevent failure. Examples of fasteners commonly used on ships include bottle screw, you can see the picture, assembled crane hook, bearing puller, fitted bolt, broken stud extractor, cotter pins and circlips, dowel pins, high tensile lock washer, main engine liner securing bolt, splices and grips, marine wire ropes, shackles. Understanding these tools and their correct operation is essential for safe and efficient shipboard maintenance. This is the end of today's lecture on tools, tackles, cranes, lifting appliances, and fasteners. Understanding how to properly use, maintain, test, and select these components is vital for both safety and operational efficiency in marine engineering. So, thank you for listening. We will see you all in the next video.